Now that we have discussed about triangles, the three-sided closed figure, now comes the new chapter number 8, called quadrilaterals. What is a quadrilateral? Let's see the discussion in brief for a quadrilateral. Before we discuss about quadrilateral, let's get into introduction of quadrilateral. Let's see the introduction. A quadrilateral, which we have as the word Quadrilateral. Lateral, the second word of quadrilateral, refers to straight line. A straight line which is straight, and then quadri, which refers to four. So a quadrilateral is a four-sided straight lines, that is a figure which is formed by four lines which form the quadrilateral. So four straight lines which enclose together to form a quadrilateral. Let's get back to the recap of a triangle. As we have seen, a triangle has three straight lines which are angular, and then the three straight lines, the line number 1, the line number 2, and the line number 3, join together to form a shape called a triangle. Three straight lines join together in this manner to form a triangle. Similarly, four straight lines join together to form a closed figure in the similar manner called a quadrilateral. So let's see how a quadrilateral is formed. Imagine I take four lines which join together to form a closed region. For example, I have line 1. This is the first line, and I take the other line and I join out here, say here. And I take the third line and I just join somewhere out here. This is line 3. And then I take the fourth line and then I join out here. So here my fourth line is joined. Therefore, each of the lines, line 1, line 2, line 3, and line 4 are joined together to form a closed figure. Such a figure obtained is called a quadrilateral. Four straight lines formed figure is called a quadrilateral. So here this is called quadrilateral. And of course, this formed by three lines as a closed region is called a triangle. Triangle, quadrilateral are how we connect through the number of sides or the number of straight lines which join to form a closed figure. Therefore, I define quadrilateral So let's see how we can define quadrilateral in words. Quadrilateral in definition: a closed region formed by joining four straight lines is called quadrilateral. Is how we define quadrilateral. Quadrilateral defines a closed region formed by joining four straight lines is called quadrilateral. The four straight lines being line 1, line 2, line 3 and line 4 closed to form a quadrilateral. Quadrilateral and its diagram. Now that we have defined a quadrilateral to be a closed region formed by joining four straight lines is what is called a quadrilateral, let's see an extended definition of understanding quadrilateral more better. There are two types of quadrilaterals which are formed. One are regular quadrilaterals and the other are irregular quadrilaterals, or ordered quadrilateral and unordered quadrilaterals. So let's see the other set of quadrilaterals which can be formed using the definition of joining four straight lines. Imagine I have four straight lines which are joined as given in the definition. As per the definition, I would like to form a closed region which is formed by joining four straight lines in this manner. Imagine I take the line 1 and I take the line 2 and I put it in this order. This is line 2. And next I have the line 3 which is arranged in this manner. Then I have the fourth line and the last line which is arranged from this point to this point, and then I have the line 4. So line 1 out here, line 2 out here, line 3 out here and line 4 out here. The four straight lines which are joined to form a closed region. So this is a closed region obtained by joining four straight lines. So let's see if this is a quadrilateral. Yes, according to the definition, this is a closed region formed by joining four straight lines, and this is a quadrilateral. We have the quadrilateral which are of two types. One, where the quadrilateral of this form is called ordered quadrilateral, and I have a quadrilateral of the form this, which is unordered quadrilateral. Therefore, a quadrilateral can be understood in two types. One is the ordered quadrilateral, which we have seen in the previous case, and secondly, it is the unordered quadrilateral, which is in this form. Unordered in the sense that they are not exactly in order, but they are cut in between. The collinearity of points is what we take into consideration in understanding this concept more better. Quadrilaterals are of two types: regular and irregular, ordered and unordered. But quadrilateral is a closed region formed by joining four straight lines. Any closed region obtained by joining four straight lines is called a quadrilateral, is how we understand the concept. Now that we have defined about quadrilateral, let's see the special features involved in quadrilateral. What are the different types of structures we see in the quadrilateral? Features. Features of a quadrilateral. So what are the features in the quadrilateral? Let's take a quadrilateral and discuss about all its features. For example, I have a quadrilateral of this four straight lines which form a closed region. Now in this quadrilateral, I have, let me denote this quadrilateral with A, B, C and D. So here the points A, B, C and D where the quadrilateral turns or where the two straight lines meet are called vertices. A is the point of intersection of this line and this line, B is the point of intersection of this line and this line, C is the point of intersection of this line and this line, and finally D is the point of intersection of this line and this line. And hence there are 4 points of intersection when the 4 straight lines form a closed region, and those points are called the vertices of the quadrilateral. So here the first thing which we understand is that features A, B, C, D are called vertices of the quadrilateral. So a quadrilateral is said to have 4 vertices A, B, C and D. A triangle has 3 vertices A, B and C. Similarly, a quadrilateral has 4 vertices A, B, C and D. Now let's see the angles. As we know that clearly the angle made by the 2 lines at A is this, and the angle made by 2 lines here is this, and the angle made by 2 lines at C is this, and the angle made by D by the 2 lines at D is this. So these 4 are called the angles of the quadrilateral. So clearly we see that there are 4 angles, 1, 2, 3 and 4. 4 angles for a quadrilateral and 4 vertices for the quadrilateral. As can be seen, angle A, angle B, angle C and angle D are called angles of the quadrilateral, and of course they are called internal angles of a quadrilateral. To be more specific, these are called internal angles of a quadrilateral. Is how we understand the vertices and the angles. The next thing is about the sides. The length of the side, the length of the straight line, the first straight line is AB, the length of the second straight line is BC, the length of the third straight line is CD, and the length of the fourth straight line is DA. So there are 4 different lengths which are taken from the straight line and then they are joined to form a closed region called a quadrilateral. Therefore, lengths are also taken into account in the quadrilateral. So along with vertices and the angles, now come the lengths. The line segment AB, the line segment BC, the line segment CD and the line segment DA are called lengths of quadrilateral. So here AB, BC, CD and DA are called the lengths of the quadrilaterals. The 4 corners or the 4 sides have the 4 different lengths of quadrilateral. They are also referred to as sides. Sometimes we refer to them as sides of quadrilateral. Is how I understand the meaning of each of these being lengths of quadrilateral or the sides of the quadrilateral. Both mean the same. Next, now that we have discussed about vertices, angles and lengths or sides of quadrilateral, now comes the discussion of diagonal, which is the most important concept in understanding the further properties of a quadrilateral. Let's see the diagonal in brief. Next is diagonal. let's see what a diagonal is for a quadrilateral. For example, the topic for the session is diagonal. What is a diagonal in a quadrilateral? Now that we have discussed about the vertices, the angles, the lengths or sides of a quadrilateral, the next important concept in the features of a quadrilateral is diagonal. So let's see the diagonal of a quadrilateral. Let me take a quadrilateral ABCD. Now we know that this is a four-sided closed region which is called a quadrilateral. So ABCD is a quadrilateral. Now interestingly, I would like to investigate on joining the two endpoints of the four-sided figure. For example, I have A and C. Let's see what happens if I join A and C or B and D. So let's try to join the 2 points, investigating the diagonals or joining the alternate sides. So A and C are called alternate points. And let me join this. I clearly see that the alternate points A and C and B and D are joined. I get a different kind of a region, the cross lines which form the diagonal. So here joining the alternate points A and C and B and D we clearly get the line segments AC and BD. The line segments AC and BD as obtained by joining the alternate points of the quadrilateral are what are called the diagonals. So here AC and BD are called diagonals. Diagonals are the lines which are obtained when the alternate points of a quadrilateral are joined. So here when I join the alternate points, I get AC and BD, which are the diagonals. So in this case, diagonal are defined to be the line segments which are obtained when the alternate points which are obtained when the alternate points of a quadrilateral join are called diagonals. Is how I understand the diagonal in a four-sided figure. Alternate points joined, I get two diagonals in the quadrilateral. Therefore, my learning outcome is that a quadrilateral has two diagonals. I make the learning outcome that a quadrilateral has two diagonals is what I understand as the learning outcome. A quadrilateral has always two diagonals. A triangle does not have diagonals because in a triangle, if I take the alternate vertices, I cannot draw a line within the triangle. But in case of quadrilateral, I can join 2 points. I can get two lines which are formed by joining the alternate points A and C and B and D. So in my quadrilateral ABCD, AC and BD are the diagonals. There are two diagonals which are formed in the quadrilateral, AC and BD. Now that we have discussed about all the possible properties in a quadrilateral, starting with vertices, sides or lengths, and the points and the diagonals. Now let's see the different types of angles which are possible in the quadrilateral. Angles of a quadrilateral connected with quadrilateral. Angles of a quadrilateral. The types of angles of a quadrilateral. Let's take a quadrilateral ABCD. Quadrilateral A, B, C and D. Clearly, in the previous session, we have discussed that for a quadrilateral ABCD, there are four angles which are possible. Angle 1, angle 2, angle 3 and angle 4. So there are four angles which are possible in a quadrilateral is what we have discussed. But these angles are classified into different types with their own respective definition based on the geometrical properties. As we see angle A and B, we see that they are side by side or besides each other. But when I take angle A and C, they are not besides each other. They are apart, far apart. Therefore, I make a connection between this and this angle and make equal connection between this and this, or this and this, or this and this. So we will try to see the different types of angles which exist in a quadrilateral. Note, angle A and angle B are side by side, and when the angles are besides each other, they are called adjacent angles in the quadrilateral. Similarly, when I take A and D, I get them to be adjacent to the side AD. So they are side by side. And similarly, when I take D and C, they are side by side. Therefore, they are adjacent to each other. And similarly, C and B are adjacent to each other. So these are the four pairs of adjacent angles which are identified in the quadrilateral ABCD. So these are called adjacent angles, and they are called adjacent angles because as they are side by side in the quadrilateral, therefore these four pairs are identified to be adjacent angles or side by side angles in the quadrilateral A, B, C and D. Now let's see the outcome of these two angles. Suppose I take angle A and angle C. They are not adjacent because they are not side by side, but they are opposite to each other. So let's see what these types of angles are called in the quadrilateral ABCD. First, let me take angle A connected with angle C. Angle A and angle C are not side by side, and also the other pair possible which are not side by side are angle B and angle D. So even angle B and angle D are also not side by side. So these are given with a special name called opposite angles. And why are they called opposite angles? Because they are opposite to each other. This angle is opposite to this, and this angle is opposite to this. Therefore, angle A and angle C are opposite to each other, and angle B and angle D are opposite to each other. They are called opposite angles as they are opposite of each other. Is how we identify the opposite angles and the adjacent angles in a quadrilateral. Angle A, angle B, angle A, angle D, angle D, angle C, and angle C, angle B taken in pairs are adjacent angles in the quadrilateral ABCD as they are side by side. Next, angle A, angle C, and angle B, angle D when taken in pairs are opposite angles because clearly we see them opposite to each other. Alternate adjacent angles and opposite angles in the quadrilateral ABCD. There are 4 pairs of adjacent angles and 2 pairs of opposite angles always in the quadrilateral ABCD is the learning outcome. Now that we have discussed about quadrilateral and its geometrical properties in brief, let's see the different types of structures which have the shape of a quadrilateral. Let's investigate the different possible types of quadrilaterals through the real life objects taken into consideration. Today's session is about applications of quadrilateral. So let's investigate to search for real life models which connect with quadrilateral. Let's take different objects and see how the quadrilaterals are in different shapes out in the given situations. Quadrilateral connected with real life models. Now let's see some real life models which understand quadrilaterals in a more better manner. Imagine I take this cover of a disc or a CD. The DVD disc cover out here clearly is in the shape of a quadrilateral because I understand that there are 4 straight lines, line 1, line 2, line 3 and line 4, and the 4 lines are combined to form a closed region. So this clearly is a quadrilateral A, B, C, D. Now how do I understand this front face of the quadrilateral? It is identified that this quadrilateral is not irregular in shape but regular in shape, in the manner that each of the quadrilateral corner is exactly at 90 degrees. So this is at 90, this is at 90, this is at 90 and this is at 90. Also I observe that each of the sides of the quadrilateral are equal. The length of the side out here is same as the length of the side out here, which is the same as that out here and which is the same as that out here. So all the sides are equal and each angle is 90. So I need to give some special name for this quadrilateral. So let's see the different types of real life models as we discuss. Let's go with this disc as taken out here. Then so here is what I get the shape of the disc cover when I draw on the board. So this is formed by line 1, line 2, line 3 and line 4, a 4-sided figure with special geometrical properties that each angle is 90 degrees, 90 degrees, 90 degrees and 90 degrees. And also I observe that length of each corner For example, I take the four corners as A, B, C, D. When I take a more clear picture of this, I have A, B, C, D in which my each angle is 90. As a special case, I have all the angles to be exactly L-shaped 90 degrees. And I also observe that for this model, each of the lengths are equal. That is, my length AB is equal to length BC, equal to length CD, equal to length DA. That means all my four sides are equal in length. So let's see, with each angle being 90 and all sides equal, what we can define for this kind of a quadrilateral as a special case. So interestingly, in this case, I see that for this real life model in which each angle is 90 and all sides are equal is called a square. A quadrilateral in which each angle is 90 degrees and all sides are equal is called a square. The special name I give for a quadrilateral whose first special case being that each of the corners is exactly at 90 degrees angle and that all the lengths of the sides are equal is called a quadrilateral, given by the special name square. A quadrilateral in which each corner angle is 90 degrees and the lengths of sides are equal is called a square. Square, a special case of a quadrilateral taken through the real life model of the disc cover cut. Now let's take another real life model to see the different quadratic shapes which are available in mathematics. The next real life model is this cardboard frame. Now here, when I see this, the first thing I investigate is that this is a closed region formed by four straight lines. Line 1, line 2, line 3 and line 4. So each of the four lines form a closed region. So definitely this is called a quadrilateral. But let's see the special features in this quadrilateral. In this case, initially when I start with angle, again here I see that each angle is 90 degrees. So every angle corner which I take out here is 90 degrees. Therefore, as in the previous case, similarly in this, I have a frame which is taken on the board. I see that the first thing I observe is this is the special feature which is observed in case of every corner being at 90 degrees. But let's see the lengths of sides. As I see that this length is shorter than this length because this length is longer when measured in length and this is shorter when measured in length. So obviously these two sides are bigger in length and these two sides are smaller in length. So the second thing what I observe is that the first thing, let me write here, angle A, angle B, angle C and angle D are all each equal to 90 is my first observation. My first observation is with each angle being 90. My second observation is that the line segments AB and CD are bigger than the line segments AD and BC, are larger lengths. These two are the larger lengths is what I observe, and these two are the smaller lengths. So my AD and BC are smaller lengths. So ABCD are larger lengths, ADBC are smaller lengths. Also, I see that when I see the frame clearly, this length seems to be exactly equal to this length because these two are 90 degrees, therefore they are parallel. So the next thing I observe is because these two are 90, these two are parallel and these two are parallel. So I see that the top line and the bottom line are parallel to each other, and the rightmost line and the leftmost line are both parallel to each other. So the third observation out here is that AB line segment is parallel to DC and AD is parallel to BC is what I observe in this case. Also, I observe that because these two are parallel and these two are parallel, I see that this length is exactly equal to this length and this length is exactly equal to this length. That is, my length here is equal to this and my length here is equal to this. So my third observation is my AB is equal to DC. The length AB equals length DC and my length AD equals length BC. Is how I get the two pairs of lengths being equal. So finally, I see that this frame has four specific geometric properties, each angle being 90, each of the angle being 90, and AB and CD are larger lengths. So AB and CD, these two are larger lengths and the other two are smaller lengths. As can be seen, this length and this length are smaller lengths. Similarly, I see that AB parallel to DC, so this is parallel to this. They have equal distances in between and these two are also equally parallel in the case. My third observation is this equals this, that is, this length on the top is same as this length on the bottom, as I can investigate through measuring tape to see if they are equal. They are equal. Therefore, this equals this and this length equally is equal to this. So these are the geometric properties I identify. Now let's see how we can connect this with the special case of a quadrilateral. So I have totally these geometric properties with each angle being 90 degrees, opposite sides being parallel to each other and opposite sides are equal, and there are two larger lengths and two smaller lengths is what we observe as the complete geometrical features. So if a quadrilateral has each angle 90 and opposite sides are equal, then such a quadrilateral is called a rectangle, a special case of a quadrilateral. So let's see a quadrilateral. A quadrilateral whose each angle is 90 and opposite sides are equal. Each angle is 90 and opposite sides are equal is called a rectangle. A quadrilateral whose each angle is 90 and opposite sides are equal is called a rectangle, a special case of a quadrilateral. All four sides equal and each angle 90 is a square, and all four sides not equal but opposite sides equal and each angle 90 is called a rectangle. Rectangle, a special case of a quadrilateral, is how we understand the special cases of a quadrilateral. Now let's see a special case of a quadrilateral called parallelogram. Now that we have discussed about square and rectangle, now comes the important definition called a parallelogram, derived from a quadrilateral. What is a parallelogram? Parallelogram. The word parallelogram itself says that a closed figure formed by parallel lines. So let's see the special case in terms of a quadrilateral. So here the word parallelogram itself has the word parallel, which means the four straight lines which are formed by forming a closed region, that is the line 1, the line 2 and the line 3, which is parallel to this. The condition is that all four straight lines which are joined together to form a quadrilateral must be parallel. The pair must be parallel, is how we understand parallelogram. The third line which I take must be parallel to the first line, and the fourth line which I take, the condition is that that fourth line must be parallel to the line 2. That means if I take out here, then this must be parallel to this, is how we understand the line 1 parallel to line 3 and line 2 parallel to line 4. All the two pairs are parallel, and thus such a line formed with a pair of parallel lines forming a closed region is called a quadrilateral, given by special name parallelogram, is how we understand parallelogram. So here I understand parallelogram to be in the shape of a rectangle, a sleeping rectangle or a slanting rectangle. In this case, ABCD is a parallelogram such that this is parallel to this, and because they are parallel, also I have noticed that the opposite sides are also equal. Let's see that in brief. Observations I make here are that in quadrilateral ABCD, my line segment AB is parallel to line segment DC, and my line segment AD is parallel to line segment BC. Is parallel to BC. Therefore, opposite sides are parallel to each other. Similarly, I notice that when two pairs of opposite lines are parallel, their lengths are equal. That is, this length equals this and this length equals this. Also, I notice the line segment AB is equal to line segment DC, and my line segment AD is equal to the line segment BC. So therefore, in this case, we see that such a quadrilateral ABCD which satisfies these two properties is called a parallelogram. Is how we understand the quadrilateral as a special case with a parallelogram. Parallelogram. Let's define parallelogram in words. A quadrilateral in which opposite sides are parallel, and of course when they are parallel they must be equal. Of course, equal in length. Is called a parallelogram. Is how we understand the parallelogram. Parallelogram, a quadrilateral in which opposite sides are parallel and the opposite sides are equal in length, is called a parallelogram. A quadrilateral with a special case of opposite sides parallel and equal is given by name parallelogram. Now let's see the angle sum property in a quadrilateral. Angle sum is today's session. As we have seen in the case of a triangle with three sides, obviously there are three angles in a triangle. The angle sum property in a triangle was defined to be that sum of three angles in a triangle equals 180 degrees. What would be the sum of all the angles in a quadrilateral is the biggest question out here. So let's investigate the sum of all the four angles in a quadrilateral. What would be the possible value of when I take all the four angles and add up? So let's take a quadrilateral ABCD. So here I have A, B, C, D, which is a four-sided closed figure quadrilateral. This is angle A, this is angle B, this is angle C, and this is angle D. So here I have four angles, angle A, angle B, angle C, and angle D. Let's sum up to see the property. So what does angle sum property define? Angle sum property. Angle sum property says my angle A plus my second angle B plus my third angle C plus my fourth angle D, which is called sum of all the four angles of a quadrilateral, which is equal to 360 degrees, is how I define angle sum property. Sum of all the four angles in a quadrilateral must equal 360. Sum of all three angles in a triangle equals 180, and sum of all four angles in a quadrilateral equals 360. Is how we define the angle sum property. Let's communicate this in words. Learning outcome here. What is that? Sum of all angles in a quadrilateral is 360. That's how I define the angle sum property. Sum of all angles in a quadrilateral inside the quadrilateral must be equal to 360 degrees. Is what we understand as the angle sum property.